What's up guys, Shawnthebro here, and in today's episode of the fighting game tutorial series and converting the fighter from 2.5D or 2D to 3D, we're going to be going over how we can make this transition for testing a lot easier. So when we come into our game here, you will notice that we are in our 2D or 2.5D fighter. This is our regular fighter, so we can do everything that we can normally do in the fighter. If I try to do something that I can only do in 3D, such as move forward or move backward, I'm not able to do it. Nothing's happening. Previously, to this point, we'd have to go change a bunch of variables, change the constraints on our character blueprint, and even change animations. We can implement a method, a cheat, from our console commands or an input or whatever you want it to be to switch between the two modes. You could even use this to switch real time in your game if you wanted a 2 and 3D fighter in one game. Like you could actually switch between them in the middle of a fight, which some games have done like Pokken Tournament. But this isn't really set up for that. This is just for us to debug. So I have a console command here that I'm calling cheat enable 3D mode, and then I pass it a true or a false. When I run this console command, you'll see that the character on the right automatically flipped via rotation. So they're not just flipped like when I jump over a character. These characters are actually rotating now when we pass over each other. And I can also walk forward and walk backward. Now understand that the animation is not working in 3D space because of the previous episode on converting our fighter to 3D. In that episode we stopped using velocity. Instead what we did was set actor location. I mentioned the next 3D episode was going to be on fixing the animations. It'll be the next one after this. Now we're also working on the camera, huge camera changes in the fighting game series, and I'm doing a lot of that for our 3D fighter. So note that the camera work for the 3D fighter is coming very, very soon as well. When I am to run this cheat to disable it, then I can no longer do 3D movement. I can only do my regular 2D stuff. But it is going to get a little bit weird if you're not at the exact angle that 2 or 2.5D requires. Everything can't do exactly what it's supposed to do. That's why I said this isn't really meant for transferring between these modes in a single match. It's really just for debugging. That way we can just launch up our game without changing any of our variables and then explore both methods of play. If you want to get caught up in the whole series and check out how we've done everything from our 2D fighter and hitboxes to our 3D fighter movement and all sorts of other fun stuff, feel free to check out the entire playlist in the top right corner right here. Alternatively, if you only care about the 3D fighter and 3D fighters in general, I still recommend you watch all these episodes before this on converting the fighter from 2.5D to 3D, because there's a lot of stuff that we're doing in there that is going to be important. So I'll link you to the first episode of the 2.5D to 3D conversion right here in the top right corner. That way you can get caught up. With all that out of the way, we can go ahead and get started. This is a code and blueprint tutorial series. We're going to be doing everything in the code today. So first things first, we go to Visual Studio. We go to where we want to add this cheat. So I add my cheats in fighter template game mode, and so continuing to put them in here makes sense. So I'm going to fighter template game mode.h. I'm scrolling down to my functions here, and I have my cheats all lined up. I'm going to add a new one today. Cheat enable or disable three-dimensional 3D fighter mode. U function of exec. That is what allows us to use it as a console command with a category equals cheats so we can find it more easily. The function itself is void cheat enable 3D mode with a boolean of should enable. So if the boolean is true, then 3D mode is going to be active, and if it's false, then it's going to be inactive, or 2D and 2.5D is going to be active. I'm actually going to make this a default parameter. So bool should enable equals true here. This means if we don't pass it a parameter, it will assume true. So if we just call this cheat and don't write true afterward, it will convert us to the 3D mode. In my personal case, when I'm using this cheat, it's going to be to enable 3D mode more often than it is to disable 3D mode. So defaulting it to true just saves me a little bit of time when I have to enter that cheat. Once you're ready, go into fighter template game mode.cpp and scroll down to where you want to make your function. So I have all my cheats right here. I've added a new one for today's episode. Void a fighter template game mode, : cheat enable 3D mode, bool should enable. First things first, we need to get our game instance, because if our game instance is not valid, then we have bigger problems and we probably can't change modes. If auto base game instance equals cast to u base game instance using get game instance. So literally what this does is get the current game instance in the project, then we're casting it to our base game instance type because we have specific variables in base game instance that we want to modify here, such as the is fighter mode 3D boolean. The result of this cast is being set into this variable. base game instance, and if it's true, this if statement will succeed. So that means it's a valid game instance. We could successfully cast it. So if we did, we can go into the if statement. Otherwise, we don't do anything at all. Next thing I want to do is set up our plane constraints. So one of the biggest differences between 2D fighter mode and 3D fighter mode is the plane constraints. In 2D fighter mode, we were setting this boolean in our character movement component. So if we go to our character BP, base character BP, and we go to our class defaults and look up constraint, it has this planar movement section, and we were setting the plane constraint normals to be 1.0 on the x-axis. The other ones were 0. Or basically, we're constraining movement on the x-axis. It means we can't move off of our starting point. So if we look at our level here, the x-axis is the depth, as you can see by our little diagram here. So we couldn't move forward toward the camera or backward away from the camera. And that's what we want for a 2D or 2.5D fighter. In the 3D fighter, we don't want that. But instead of going in here and changing this every single time, we can go to the code and we can set up constraints for these two modes. So the 2D fighter mode is exactly what we have in the character blueprint. F vector plane constraint 2D equals F vector 1.0F, 0.0F, 0.0F. So only constrain movement on the x-axis. The 3D fighter mode constraints are basically non-existent. We can move on every axis. Went ahead and made an F vector and a variable for this anyway, but just know it's just a 0 vector. So F vector plane constraint 3D equals F vector 0.0F, 0.0F, and 0.0F. Now once we have these variables set up, we actually have to assign it on the characters. I want to assign this for all the characters. You could just do it for the active character. I went ahead and made life easier for myself because this is just a cheat code. It doesn't have to be the cleanest. It's not going to be firing all the time. In fact, it's not really ever going to fire unless the player is using a console command. For the first one here, we're going to loop through all the team 1 characters. So for integer I equals 0, I is less than team1 characters.num ++ I. Then I'm checking if should enable is true. Remember, that's the parameter that gets passed into this function. If it's true, we want to set team1 characters at index I, grabbing their character movement component, get character movement, set plane constraint normal, and we're going to set it to the appropriate value. So if we're enabling the 3D fighter mode, we want to use plane constraint 3D. Else, this means we're disabling 3D fighter mode, so we're going to do the same thing, team1 characters at index I, get character movement, set plane constraint normal, but we're going to pass it plane constraint 2D. So this will set up the plane constraints for all of our characters. After this logic, I'm doing something else on all the characters, and that is going to be flipping them to face the correct direction. So when we switch to 3D mode, the characters rotate toward each other. In regular 2D and 2.5D fighter, the characters flip their scale on the y-axis to face each other. Because they're doing this, if we don't reset their scale back to 1.0 instead of making it -1.0, they're not going to be rotated appropriately in the 3D mode. So I copied this logic from the tick function of the 2D fighter. We don't actually need all this. I'm going to clean it up in a second, but I'm just showing you this is exactly the code that we have to flip the scale back to the regular value on the y-axis for our flipping characters logic. So I'm going to comment here, reset the character default scale. We are getting the relative transform of the character's mesh. So we're using team1 characters at index I, get mesh, which is getting their skeletal mesh component and returning the relative transform into this variable, which is just called transform. And then from the transform, we're getting the scale and making a variable of that. So transform.getScale3D, and we're setting the scale variable to that value. Then I'm using scale.y and setting it equal to 1.0. So even if it was -1.0 before, it's being overwritten. And now it's 1.0, which is our default scale. And then I'm using the transform to set the scale back to that value now that we've modified it. And lastly, team1 characters, get mesh, set relative transform back to the transform variable that we've modified. So all of this is to basically say, just set the scale of the mesh back to the default value and set the whole transform back to that initial transform. We're going to basically do the exact same thing that we just did, except we're going to do it on team 2 characters. So same for loop, for integer I equals 0, I is less than team2 characters.num ++ I. Only difference here is the team 2 characters array is what we're looping through, not team 1 characters. And for anyone who may be unfamiliar with the tag team aspect of our game, this is just an array of our characters. So if you're not using tag team, you can just go ahead and use your active team 1 character, active team 2 character variables, or as you may know them, player 1 and player 2 variables in our game mode. Next thing I'm doing is checking if we should enable, just like before, because if we are, we're going to use team 2 characters at index I, get their character movement component, call set plane constraint normal, passing in plane constraint 3D since we're going to the 3D mode. Else, if we shouldn't enable, then we're going to use team 2 characters at index I, get the character movement component, set plane constraint normal, passing in plane constraint 2D. Then we're going to get our transform from team 2 characters index I mesh relative transform, get the scale from that transform, set scale Y back to 1.0, not negative 1.0, set the scale back on the transform, and then set the team 2 characters at index I meshes relative transform back to that transform variable. Let's go ahead and copy this comment down here. And then after both of these for loops, we have to update the variable in our base game instance because there is a variable in here that is used to determine if this is a fighter mode 3D, and we use that for some other things if certain inputs are valid, and even to actually rotate our characters versus flipping them in the tick function. So base game instance is fighter mode 3D equals should enable, again, the variable being passed into the cheat here. Now going to the fighter template character, also something we should do here that we didn't do in the previous episode of the 2D to 3D conversion. So I want to go down to move forward 3D function. Right here. And in here, everything you see highlighted is what we had in the function before. But we could actually call this function in 2D and 2.5D mode. Since we're no longer using movement inputs, but instead using set actor location, we could actually avoid the constrained to plane logic, and we could actually move in the foreground and background in our 2D and 2.5D fighter. So encompassing everything in this function, we're going to want to add 2 if statements. The first one is going to be getting our game instance, so same as before, if auto base game instance equals cast u base game instance, and we're passing in get game instance. If this succeeds, the next one is if base game instance is fighter mode 3D. If this boolean is false, this means we won't do anything in here and thus no issue. If it's true, we will go in here and then we'll use the appropriate logic for moving forward. So also no issue. Anyway guys, that's all I got for you today. Thank you so much for watching. If you enjoyed this video, please subscribe and I really appreciate it. If you want to support the channel further and check out everything we have to offer, you can go to the Patreon, YouTube membership, or Discord subscribers like so many of you kind souls have. You guys are amazing, and I am so appreciative of you, so thank you so much. If you ran into any problems while following this tutorial or any of my tutorials, feel free to join the Discord community. There's a link in the description, and I would be happy to help you. Thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.